This is the second of 3 videos where I'm talking about functions in the unit circle. In this video, I'm talking about functions. Last video, we talked about radians in the unit circle. And what I wanted you to get out of that, take away from that, was that positive x-axis is 0 radians, or 2 pi radians if we go all the way around. 90 degrees is pi over 2. 180 is pi. 3 pi over 2 is 270. Okay, so when we deal with functions, there's a couple things. First, our angle will always have a vertex at the origin. Okay. Second, the terminal side, that angle will be measured like this. Now, there are times when you're going to use an acute angle, and you'll get into that sort of later. And a lot of the way I do things in the book helps you avoid finding reference angles and stuff like that, because no one wants to find reference angles. Good news is you don't have to. We'll talk about that some when we do this problem at the bottom of your screen. If the ACT gives you a trig problem and they don't give you a triangle, you're going to want to make your own right triangle. Now, up here I say x is adjacent, y is opposite. Let's explain why that is. Now that I have a right triangle, it may be kind of obvious, or maybe not. I don't know. Look, this is my angle. This is the side that's not the hypotenuse, right? So that's adjacent. That is the x-axis. This isn't the y-axis, but that y distance is parallel to the y-axis. And so the y, I mean, you can just find the length of both sides of the triangle by a coordinate point. Let's say it's square root of 3 over 2 and 1/2. So the length of this x side, this adjacent side, will be the square root of 3 over 2. The length of our y side will be 1/2. And by the way, if you run these through the Pythagorean theorem, they'll come out to 1, your hypotenuse, which it should, right? This is a unit circle. The radius of a unit circle is 1. Hypotenuse is always going to be a radius of that unit circle. So here's the secret, okay? Depending on the quadrant, some functions will be positive and some functions will be negative. Remember, in trig graphs, they oscillate up and down, right? Or in tan, they go, that was a pretty bad finger tan graph, but you get the idea. How do you know which? Well, think about what the function is composed of. Let's look over here. Sine would be y over hypotenuse. All right, well, that's going to be positive, right? Because everything's positive over here to begin with, but the thing I haven't told you yet is the hypotenuse is a distance. Hypotenuse is always positive. Can't have a negative distance. So it'll be positive here. So whenever y is positive, sine positive. Y negative, sine negative. Wherever x is positive, cosine is positive. And whenever x and y the same sign, tan is positive. Now, there are a bunch of little graphs that you've probably seen before, the breaking up the quadrants, and you could use that ax thing. All positive, cosine positive, tangent positive, sine positive. Right? That actually works pretty well, ACTS. You just run it through. But just think about it in terms of y and x. I think that's the simplest. So here's the secret about these kinds of questions. They like them a lot. But the way they're usually going to work is this. There's only going to be one answer that's in the right quadrant. So let's take a look. So we're looking for a positive sine value, positive 0.534. Well, it's going to be positive here and here. So either between 0 and pi over 2 or pi over 2 and pi. What? A looks promising, so let's hang on to it. B, 5 pi over 4, that's over here. That's out. B's out. C, 7 pi over 6, well, That's still over here, right? And that's still third quadrant. What about D? 3 pi over 2? No, to 5 pi over 3. That's like in here. D is out. And E, 9 pi over 5, that's like over here to, no, I don't think so. So essentially, you turn most unit circle, not all, but most unit circle problems can be turned into Markov problems based on the quadrants. Remember, you don't have to have a calculator to do this, right? So there's going to be workarounds. Sure, you could do this by finding the reference angle, right? But you don't need to. Just look for the quadrants to fit. That's all you got to do. Okay, make sure you check out the third video in this set and work these problems. I want you to get this point in the bank.